Welcome to Click Academic. This is lesson 3 on the series of set theorem and logic. We'll be discussing on implicative, which is under connectives in this lesson. In our previous class, we discussed about connectives. We discussed some of the connectives. So today we are going to continue with some of the connectives that we left behind. The first one is what? Implicative. This implicative, as I said, is called material implicative. This is another name of implicative. A compound statement compared by the connectives if, which is the then statement, is called an implicative statement. The statement that is between if and then is called antecedent, while the statement follow the then is called subsequent. Now, if you look, I'm trying to make it clear, trying to show you some diagram here. We have, let's say this is if, and then from the statement, then statement 1, then statement 2. We have statement 1, statement 2, the relation between we have then. If statement 1, then statement 2. Then this is what you call what? Antecedent. Then this is what you call subsequent. That is, statement 1 is antecedent, while statement 2 is subsequent. So, therefore, suppose P and Q are any statement, then P implies Q, which is if P then Q, denoted by P, this is true. If, that is the condition first, Q is true. P implies Q, meaning if Q is true, meaning Q here can be any value. So the value that has been implied must be true for the statement to be true. Or both P and Q are false. These are the only statements. Otherwise, the statement is false. When you have false, false, meaning it's true. But if you have true, false, so it's false. If you have false, true, it's true. That's why we say at least this implies Q. Q must be true. That's the statement. So now let's look at this example, the table here also, to show whether there is some relation. And here, we want to talk about negation. In our previous class, we didn't discuss about negation. When we say negation, let's say we have negation of P. Let's assume our P to be true. Then negation of P, when you take the opposite of truth, what will be? False. That's what we mean by negation. Then if you say negation of, let's say, Q, where Q is what? False. Then negation of false is what? Is true. This is what we mean by negation. So that, that's why I say it's a unitary connectives. So now let's discuss about this. We have the first column, P implies Q. P implies Q if and only if this Q is true, or both the statements are false. That's the condition of material implicative. So Q, we have to check Q first before P. Then is Q true? Yes, therefore here will be true. You understand? Then if Q is true, here is false, so therefore it's false. We are considering this element. Is this is true? Yes, it's true. Is this is false? Then this one is also false. Therefore, false, false is true. It satisfies the condition. Then now we just want to change our as in commutative to see whether to satisfy the commutativity. Then we say, okay, Q implies P. So at this case, you are going to consider P first before Q. Then P is true, then here is true. P is true, then here is true. False, then here is false. True, false, false, then here will be true. So now if you look at this statement and this statement, are they the same? True, truth, false, true, true, false, true, true. So they are not the same. So meaning this and this are not equal. Then, now list, as I said, negation of P. What's the negation of P? Then here is true, which will be false. True, false, false, true, false, true. That's the negation. Then here we also have negation of Q. True, false, false, true, true, false, false, true. That's, we are taking negation of each other. Then negation of P, O, Q. O mean at least one of the statement must be true. Meaning P, O, Q. You see Q is true. So therefore here is true. Then we have what? False, false. So meaning is false. Then we have what? True, true is true. We have true, false is true. Since at least one of them will be true. Then we have negation of Q implies negation of P. Negation of Q implies negation of P. Then this negation of this implies this. If and only if both are false O, negation of P is true. Then this and this are false. Then P, is it false? Is false. This one is true. This one, they are all what? Is it true or false? We say that if and only if both are what? False, O1 is what? True. Therefore, it's false. You understand? So therefore, we have to take, okay, negation of P implies negation of Q. Meaning, this implies this. False, false is true. True, false. Since Q is what? Is true. False, true is false. True, true is what? Is false. So this is all about the negation. Now, if you look at this column, or this column, you find out that this column and this column are the same. If you check this column and this column are almost the same. So therefore, we can conclude that, okay, P implies Q is equal to, because this is, we have true, true, false, false, true, 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 which is called to what? Negation of P, O, Q. Then we have this, Q implies P is equal to what? This one. Negation of P implies negation of Q. Because true, 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 false, false, true. That's just what the relation is all about. Think. So this is the end of our class. Thank you very much.